Okay, we're in Gary's garage here, and he's going to explain to us how his ground source heat pump works. This is really the heart of the system that we're looking at here, and in fact he just explained this is exactly where the oil tank used to be. So is that right, Gary? We have no oil anymore.
Yeah, the oil boiler used to sit in this corner and the pipework used to go up into the house there, so it was just a matter of taking that out and putting the heat pump in the buffer tank in the same corner, and a lot of the pipework could be utilised again.
Right. It's quite a large space that it takes up, with both this sort of thermal store buffer tank here, plus the
hot water cylinder at the top and the heat pump itself.
Heat pump underneath, right.
Yeah.
You're explaining the different temperatures here.
The system's set up so you can actually see what temperature the brine's coming in at. So you can see the brine coming in at 11 degrees out of the ground. That's the temperature out of the ground outside, and then it's actually going out at 7 degrees, so it's gaining 4 degrees from the ground temperature,
right,
to start the whole process off, whereby it's evaporated and then it's condensed, and then that rises the temperature a bit higher, and then it heats the hot water which runs through the pipes.
And just explain a bit more about how the thermal store here works.
Well, you do have a hot water tank as part of the unit, but it's a fairly, well, a medium-sized sort of hot water store. But the buffer tank gives you that bit extra. It's 220 litres, so you can sort of store hot water at a better sort of temperature and a better volume, and it sort of keeps its thermal heat.
The heat pump itself is continually coming on and turning off as needed to boost the temperature up.
We've got the room temperature set to 18 degrees there, so it's actually just come on just to top up the house at the moment. It's quite a good system, as we thought we'd have to have a thermostat inside the house. But the installer told us that as long as you set that at 18 degrees, that actually calculates the temperature of the water going into the house and the temperature of the water coming out, so it can actually calculate how hot the actual temperature of the house is, which I must admit I found whether it's going off now, it's just topped it up. So yeah, I found it a bit strange. I thought, how can that be? So we actually had a thermometer in the living room, and it does do 18 degrees. It does tie up with that, which seemed
reassuring.
Yeah.
And in terms of how long did it take you to put this in, and sort of costs and things like that, was it?
Yeah, well, it took them probably about 4 to 5 days, I think. That was including all the trench work in the back and putting the cables, the cables in. It was probably just over the £12,000 mark for all the trench work and all the installation in here.
Just final one, hot water. How does your hot water system work if someone wants to have a shower or a bath?
Basically, just like a normal hot water cylinder. The hot water's in there. It goes to the shower, which is on the mains.
And you find it's hot enough?
Yeah. It's I think it's 46, 47 degrees, which is hot enough.
Perfect.
Yeah.
Okay.
The other thing it does do, because the water does run round the system at a slightly lower temperature for the heating and hot water, every between 7 and 14 days, the auxiliary heater in the system takes the water up to above 60 to kill any Legionella potential, because it is running at a lower temperature. In a gas system, you're running at 80 degrees, so you've no chance of Legionella, but because this does run at lower, you have to boost the water up to above 60 just for a small period to kill the Legionella, if there is any. And then it goes down again. So that just happens every 7 to 14 days.
And this combination of energy generation in your back garden, combined with heat generation also from your back garden, all using electricity. It's a nice way of offsetting, isn't it, to combine these technologies together rather than treat them independently.
Yeah, yeah. I think it has to be an all-encompassing system where you've got 3 or 4 different technologies working for each other. I don't think you'll solve a problem without using at least probably 3 technologies to make your house a sort of sustainable.
Yeah, that's a very good point.
Yeah.
Yeah. Thanks, Gary.
Mm.